My dear students, welcome to Mathological. In today's session, we are starting the topic of quadrilaterals, a very important topic. And we'll be starting with general quadrilaterals. We're doing some theorems today. And then from tomorrow, we'll be starting specific topics in quadrilaterals. Okay, start करते हैं. So, in quadrilaterals, quadrilaterals are quadri यानी four lateral sides. So any closed figure with four sides, closed figure with four sides. So a general quadrilateral. And then we'll be covering up trapeziums, kites, parallelograms, and then rhombus, a specific type of parallelogram, and rectangles, which will also include squares. So this will be basic structure of quadrilaterals. Okay, start करते हैं. So basically, a quadrilateral has four sides, and sum of angles in quadrilaterals, sum of angles is 360 degrees, because basically a quadrilateral is two triangles stitched together. So 180 degrees is sum of angles for the first triangle, 180 for the second. So sum in quadrilateral, sum of angles is 360 degrees. Is that clear? Okay. Now coming to area of a quadrilateral. Area of a quadrilateral. Let us make the diagram first. A general quadrilateral ABCD. None of the sides are parallel, none of the sides are equal. Okay. So if we are drawing one diagonal, diagonals in the quadrilateral are BC, BD, and AC. These are the diagonals. Okay. Clear? Let us say angle between the diagonals is theta. This angle is theta. So this angle will be 180 minus theta. Vertically opposite angles will be equal. So this will also be theta, and this will also be 180 minus theta. So if intersection point is point O, so area of triangle, area of basically quadrilateral ABCD will be equal to areas of triangle OAD plus triangle ODC plus triangle OBC plus triangle OBA, and area of triangle OAD will be equal to OA into OD, 1 by 2 OA into OD sin theta. ठीक है, 1 by 2 OA into OD sin theta. Let us say OA is small a, OD is small d, OB is small b, and OC is small c. So triangle OAD का एरिया हो जाएगा 1 by 2 into A into D sin theta, प्लस ट्राइंगल ODC का एरिया हो जाएगा 1 by 2 CD sin 180 minus theta, प्लस ट्राइंगल OBC का एरिया होगा 1 by 2 B into C sin theta, plus 1 by 2 for triangle OBA, 1 by 2 AB sin theta, sin 180 minus theta. And I believe you have already seen the topic of triangles, because वहां पे ये सब चीजें हमने डिटेल में डिस्कस किया. Okay, so sin 180 minus theta will also be equal to theta. This will also be equal to sin theta. So this will become equal to 1 by 2 AD sin theta plus 1 by 2 CD sin theta plus 1 by 2 BC sin theta plus 1 by 2 AB sin theta. 1 by 2 AD sin theta, plus 1 by 2 CD sin theta, plus 1 by 2 BC sin theta, plus 1 by 2 AB sin theta. Now in the first two, if you take 1 by 2 D sin theta is common, A plus C बच जाएगा, and A plus C क्या है? A plus C is diagonal AC. A plus C is diagonal AC. Similarly, B plus D is diagonal BD. So first part में हमारा आ जाएगा 1 by 2 D sin theta multiplied by AC, plus second part में 1 by 2 B sin theta multiplied by again A plus C which is AC only. और फिर फाइनली तुम D और B को ऐड कर लोगे, B plus D will be BD. So effectively this becomes 1 by 2 into AC into BD sin theta. So area of a quadrilateral becomes equal to 1 by 2 diagonal 1 into diagonal 2 into angle between those two diagonals, 1 by 2 D1 D2 sin theta. An important formula. क्या ये क्लियर होता है? ठीक है, एरिया ऑफ अ क्वाड्रिलेटरल बिकम्स 1 by 2 D1 D2 sin theta. ठीक है, ओके. नाउ if area is 1 by 2 D1 D2 sin theta, and let us say there is a question that diagonals of a quadrilateral are 12 and 15 centimeter. Find the maximum area of the quadrilateral. Maximum area of the quadrilateral. So what will be the maximum area? भाई diagonals का length हमें given है 12 and 15. So area of the quadrilateral will be equal to 1 by 2 into 12 into 15 into angle between the diagonals which is sin theta. And sin theta का maximum value कितना होगा? 1 होगा, because बाकी सब तो fixed है. Maximum value of sin theta is equal to 1 और कब होगा? When theta is equal to 90 degree. So basically when diagonals are perpendicular, when diagonal 1 is perpendicular to diagonal 2, then area will be maximum. So when the diagonals are perpendicular, the angle between diagonals is 90 degrees, then area will be maximum for a given value of the length of diagonals. So maximum area will be equal to 1 by 2 into 12 into 15, and that is 90 square units. Is that part clear? And diagonals are perpendicular in a quadrilateral when either it is a square or a rhombus. So diagonals are perpendicular when either it is a rhombus or a square. In a square, side lengths are equal, also diagonals are also equal. So in case of a square, D1 is equal to D2. But in this question, since diagonals ka length is different, so when the angle is between them is 90 degrees, that will be a rhombus. That will be a rhombus. क्या ये part clear है? The maximum area of the quadrilateral will be when the quadrilateral will be a rhombus. Okay. ठीक है. छोटी छोटी बातें हैं बट इंपॉर्टेंट बातें हैं, इनको समझना है, याद नहीं करना है, समझ लेना है, ताकि जब अप्लाई करने का टाइम है तो अप्लाई कर सको. ओके, ठीक है. नाउ अनदर इंपॉर्टेंट प्रॉपर्टी, if we have a general quadrilateral, a quadrilateral in general, ABCD, and diagonals are intersecting at point O. Let us say area of part AOB is S1, of part BOC is S2, S3 for the part DOC, and S4 for the part AOD. So if areas of respective triangles are S1, S2, S3 and S4, S1, S2, S3, S4 areas है. So another important property is that S1 into S3, this is equal to S2 into S4. Okay, S1 into S3 is equal to S2 into S4. Okay, and the proof is very simple. S1 is equal to 1 by 2 if this angle is theta. So this is also theta, this is 180 minus theta, this is 180 minus theta. तो sin theta and sin 180 minus theta सेम होगा. तो S1 हमारा आ जाएगा 1 by 2 into AO into BO sin theta. Similarly S2 आ जाएगा 1 by 2 BO into CO sin theta. S3 will be 1 by 2 CO into DO sin theta. And S4 will be 1 by 2 DO into AO sin theta. अब बस मल्टीप्लाई कर लो S1 S3 को और S2 S4 को, यू विल फाइंड इट दैट दीज आर इक्वल. इजी प्रूफ है. ओके क्लियर है. अब क्वेश्चंस करते हैं एक दो. सो फर्स्ट क्वेश्चन, इन अ क्वाड्रिलेटरल ABCD diagonals AC and BD intersect at point P. Area of triangles PBC and PAD are 27 and 12 respectively. To find the minimum possible area of the minimum possible area of the quadrilateral ABCD. So what will be minimum possible area of the quadrilateral ABCD? That is the question. So quadrilateral ABCD has AC and BD diagonals intersecting at P. And area of triangle PBC and PAD are 27 and 12. PBC का area is 27 and for PAD area is 12. So two values are given of the opposite triangles, and let us say this area for this triangle is S1, for this is S2. So we know S1 into S2 for these given triangles, this will be 12 into 27. ठीक है, because the given property was that area product of areas of triangles opposite to each other is equal to S1 into S3 is equal to S4 into S2. So by the same logic, by the same property, S1 into S2 in this case will be equal to 12 into 27. So product of areas is fixed, product of the areas is given, but question हमसे पूछा है minimum possible area क्या होगा of the quadrilateral. तो area of quadrilateral ABCD is equal to 12 plus 27 plus S1 plus S2. And if we have to minimize this area, so to minimize this, we have to minimize value of S1 plus S2. S1 into S2 fixed है, S1 plus S2 को हमें minimize करना है, तो AMGM लगा देते हैं. Arithmetic mean greater than equal to geometric mean of S1 and S2. तो S1 plus S2 by 2, this will be greater than equal to square root of S1 into S2. So S1 plus S2 will be greater than equal to 2 times square root of S1 into S2. Or to generalize this, if we have been given product of two numbers, हमें two numbers का अगर product given है, तो sum of those numbers will be minimum when those numbers are equal. If product of two numbers is already given, then sum of those numbers will be minimum when the numbers are equal. Okay. If product of two numbers is given, then sum is minimum when numbers are equal. Okay. So S1 into S2 है 12 into 27. 27 is 3 cube. 12 is 2 square into 3. So this will be 2 square into 3 to the power 4. So square root of S1 into S2, because S1 plus S2 का मिनिमम वैल्यू कितना होगा 2 square root of S1 S2. तो square root of S1 S2 will be equal to 2 into 3 square, which is equal to 18. ठीक है, so both numbers should be equal to 18. If both S1 as well as S2 are equal to 18, in that case sum of areas will be minimum. If both S1 and S2 are equal to 18, then sum will be minimum. तो sum हमारा कितना आ जाएगा? Sum will come out to be area minimum will be equal to 12 plus 27 plus S1 is also 18, S2 is also 18. So this is 36 plus 39, 75. So 75 will be our area. Okay. ठीक है. नेक्स्ट क्वेश्चन, आगे बढ़ते हैं. Let us say there is a quadrilateral with side lengths ABCD, ABC and D. So if D is the largest side, of the quadrilateral, in that case largest side should be less than sum of all the other sides. Length of largest side should be less than sum of lengths of all the other sides. This is condition for formation of a quadrilateral. Condition for formation of quadrilateral. Quadrilateral तभी form हो पाएगा when the largest side is less than sum of all the other three sides. Okay. इस पे भी एक क्वेश्चन कर लेते हैं शॉर्ट में. All four sides of the quadrilateral are 8, 10, 20 and x respectively. Find the number of possible integral values of x. So four sides of a quadrilateral are 8, 10, 20 and x. 8, 10, 20 and x. So the condition is that fourth side of the quadrilateral should be less than sum of all the other three sides. तो पहले तो पता होना चाहिए कि कौन सी साइड हमारी लार्जेस्ट है, और ये तो अभी पता नहीं है. सो लार्जेस्ट साइड कैन बी 20 और इट कुड बी x, बिकॉज 8 और 10 तो डेफिनेटली 20 से छोटी है. तो लार्जेस्ट साइड के लिए दो केसेस बनेंगे हमारे. इट कैन बी 20 और x. सो फर्स्ट केस व्हेन x इज लेस देन 20. सो इफ x इज लेस देन इक्वल टू 20, तो 20 इज द लार्जेस्ट साइड. So 20 should be less than 8 plus 10 plus x, and hence x should be greater than 2. So value of x should be greater than 2. Second condition, when x is greater than 20, then x will be the largest side, and x is the largest side. In that case, x should be less than 8 plus 10 plus 20. So x should be less than 38. Which implies that x should be greater than 2 but less than 38. So कितनी values possible होंगी? If x is greater than 2, minimum value will be 3, 4, 5, 6 and so on. And since x is less than 38, the largest value will be 37. So from 3 to 37, all values are possible. So number of possible values will be 37 minus 3 plus 1. So that will be 37 minus 2, 35 values are possible for x. Answer will be 35. ठीक है, clear? Now let us do a few important theorems. First of which is British flag theorem. British flag theorem, and this theorem is applicable for rectangles. And since square is also a rectangle, so is square as well. So for rectangles and squares. So if there is a rectangle ABCD, ABCD, and there is a point P that can be inside the rectangle, or it can be on the rectangle, यानी कि on the boundaries, or it could be outside the rectangle. So P can be inside the rectangle, on the rectangle, or it can also be outside the rectangle. Anywhere, P can be a point that is anywhere. ठीक है? So if P is any point inside, on, or outside the rectangle, in that case, the property says, the theorem says, let us say this is point P. So PA तो कनेक्ट करते हैं, PC, PB and PD, all of them are connected, and the property says that PA square plus PC square is equal to PB square plus PD square. PA square plus PC square is equal to PB square plus PD square as per the theorem. Is that clear? Okay. Which implies distance of the point from opposite vertices, ठीक है, डिस्टेंस ऑफ द पॉइंट फ्रॉम वर्टेक्स ए का स्क्वायर प्लस डिस्टेंस ऑफ द पॉइंट फ्रॉम वर्टेक्स सी का स्क्वायर, दैट इज इक्वल टू डिस्टेंस ऑफ द पॉइंट पी फ्रॉम वर्टेक्स बी का स्क्वायर प्लस डिस्टेंस ऑफ पॉइंट पी फ्रॉम वर्टेक्स डी का स्क्वायर. Okay, and the proof is again very simple. If we draw a perpendicular from point P on vertices on lines AB and CD, let's say this length is A and this length is B. Since this is a rectangle, this length from A, let us say this point is X, this point is Y. So dx will be equal to AY. So this will also be small a, this will also be small b. And if this length is C and this length is D, so in that case this is perpendicular. So in triangle PXD, DP is the hypotenuse. Similarly triangle PXC में PC is the hypotenuse. Triangle PYB में PB is the hypotenuse और triangle PYA में AP is the hypotenuse. So PA square in triangle APY, AP square is equal to A square plus D square. Similarly in triangle PYB, BP square और PB square is equal to PY square यानी कि D square plus B square. Similarly in triangle CXP, PC square is equal to B square plus C square. And lastly in triangle DXP, PD square is equal to A square plus C square. बस अब ऐड कर लो. As proved. Okay. Clear? So next question. ABCD is a triangle. A point P is such that distances PA, PB and PC are 11, 13 and 7 centimeter respectively. To find the distance PD. What will be distance PD? So since ABCD is a rectangle, P is the point. So PA square plus PC square will be equal to PB square plus PD square. So 11 square plus 7 square. This will be equal to 13 square plus PD square. So PD square will be equal to 11 square, which is 121, plus 7 square 49, minus 13 square, which is 169. So this is 170 minus 169, which is equal to 1, and hence PD will be equal to 1. The distance PD will be equal to 1. Okay. Clear? Now next important property. Notice that there is a quadrilateral with an incircle. A quadrilateral with an incircle. Quadrilateral ABCD with an incircle. Now first important part is that not all quadrilaterals have incircles. जैसे हमने ट्रायंगल में देखा था, ट्रायंगल में every triangle has a incircle and every triangle has a circumcircle. So for 3 points, for any 3 points which are not collinear, so we will always be having a incircle as well as a circumcircle. तो एक ट्रायंगल के लिए will always be having a circumcircle as well as a incircle, but ये quadrilateral के लिए true नहीं है. So not all quadrilaterals have incircles. Okay. ठीक है. So this theorem applies only to those quadrilaterals which have incircles. The name of the theorem is Pitot Theorem. And if a quadrilateral has incircle, in that case, all the lines on the quadrilateral, all the sides of the quadrilateral, side AB, side BC, side AD, and side CD, all the sides are tangents to that circle. So AB, BC, CD and DA, all these are tangents to any circle. That is why this is also called tangential quadrilateral, because all sides are tangent to the circle. Tangential quadrilateral. And the property is that side lengths on the opposite side AD and BC, sum of side lengths on the opposite side AD plus BC is equal to sum of the remaining side lengths AB plus CD. AD plus BC is equal to AB plus CD. This is the property. Okay, clear? ठीक. Now the proof is very simple, because if you observe from one point, if two tangents are drawn on a circle, then length of those two tangents is equal. If let us say this is point P and two tangents P and PB are drawn from point P, in that case PA is equal to PB. Length of tangents from the same point are equal. Are equal. So PA is equal to PB in that case. And similarly in the quadrilateral ABCD, if the points at which the circle is, the lines are tangent to circle, let us say those points are P, Q, R and S, then AP and AS are the tangents drawn from point A, so AP will be equal to AS. Similarly, BS will be equal to BR, CR will be equal to CQ, and DQ will be equal to DP. Now if this is A, this is B, this is C, this is D, so AP plus PD will be A plus D. Similarly, BR plus RC will be B plus C. So total AD plus BC becomes equal to A plus D plus B plus C. Similarly, AS is also equal to A, BS is also equal to B, so AS plus SB, yani AB is equal to A plus B. AB is equal to A plus B, and DQ is also equal to D, and QC is also equal to C, so DC is equal to D plus C. So that is why sum is equal. That is the proof. That's it. Okay, clear hai? Okay, let us do a question. So find the length of side AD. What will be length of side AD? So DC is equal to 12, AB is equal to 21, CB is 18, so DA will be equal to AB plus CD minus BC. So 21 plus 12 minus 18. This will be 33 minus 18 and hence 15. So answer will be 15. 15 will be the answer. Okay. Next question. Find the perimeter of the quadrilateral ABCD. If we have been given this DP is equal to 6, CQ is 5 and AB is 16. So we need to find out perimeter of the quadrilateral ABCD. So if DP is 6 centimeter, then DS will also be 6 centimeter. These two will be equal. This will also be 6. Similarly, if PC is 5, CQ is 5 centimeter, PC will also be 5 centimeter. This will also be 5. Okay, clear? If AR is equal to X, so SA will also be X, and if RB is equal to Y, then QB will also be equal to Y. And as we know that AB plus CD, this is equal to DA plus BC. तो perimeter क्या आ जाएगा? Perimeter will basically be 2 times of AB plus CD. बिकॉज ए प्लस सी डी इज इक्वल टू डी ए प्लस बी सी, तो 2 टाइम्स ऑफ ए प्लस सी डी आ जाएगा, और ए बी 16 है और सी डी 11 है, तो 2 टाइम्स ऑफ 16 प्लस 11, दैट विल बी 54 सेंटीमीटर. Perimeter will be 54 centimeter. Is this clear? ठीक है, कोई दिक्कत? ओके, आगे बढ़ते हैं. सो अभी तो हमने इन सर्कल वाला कॉन्सेप्ट तो देख लिया. व्हेन देयर इज अ सर्कल इनसाइड द क्वाड्रिलेटरल, but if there is a circle outside the quadrilateral circumscribing the quadrilateral, that circle is called circumcircle. That is called circumcircle. Let us say there is a quadrilateral ABCD, and if there is a circumscribing circle, for a quadrilateral, then such quadrilateral is called cyclic quadrilateral. Cyclic quadrilateral. Okay, and A, B, C, D, the points, the vertices of the quadrilateral are concyclic. The vertices of the quadrilateral are called concyclic. Okay. अब ऐसे समझो, देखो बिल्कुल सिंपल से समझते हैं. पहले एक ट्रायंगल ड्रॉ करते हैं, एक सर्कल बना लिया हमने, एंड इनसाइड दैट देयर इज अ ट्रायंगल. द ट्रायंगल इज ABC, and this is circumcircle for triangle ABC. Now there is another point D on the circumference. Let us say this is the point D. So now this ABCD has all 4 points on the circle. So ABCD is a cyclic quadrilateral. Okay. Cyclic quadrilateral. Then let us say there is center at O, center of the circle at point O. So if you join point B and C from O, so this angle we've seen in the sessions on triangles. So this angle BOC, this will be twice that of angle BAC. So if angle BAC is equal to theta, this angle will be 2 theta. Angle BOC will be 2 theta. Will be 2 times of angle BAC. So this will be 2 theta. Similarly, if angle BDC, this angle is alpha. So this angle BOC, the reflex angle BOC, this will be 2 alpha. Double that of alpha. So angle BOC, reflex angle BOC, this will be twice that of angle BDC. So this will be 2 alpha. And sum of these two angles is 360 degrees. So sum of 2 theta and 2 alpha will be 360 degrees, and hence theta plus alpha will be equal to 180 degrees. Important property of a cyclic quadrilateral. Theta plus alpha is 180 degrees, यानी कि this angle plus this angle is equal to 180 degrees. So these are supplementary angles. Angle BAC and angle BDC are supplementary angles. Isn't it so? Sum of opposite angles in a cyclic quadrilateral is 180 degrees. Sum of opposite angles in a cyclic quadrilateral is 180 degrees. क्या ये बात अप्रिशिएट कर पा रहे हो? ठीक है, ओके. So basically, if this angle is theta 1, this angle is theta 2, this angle is theta 3, and this angle is theta 4, and this is A. एक सेकेंड, इसको थीटा 2 कर देते हैं, ज़्यादा बेटर रहेगा. एंड दिस इज थीटा 3. तो A, B, C, D. सो थीटा 1 plus theta 3 is equal to 180 degrees. Similarly, theta 2 plus theta 4 is also equal to 180 degrees. Okay, which is to say angle A plus angle C is 180 degrees. Similarly, angle B plus angle D is also 180 degrees. So these angles are supplementary. Supplementary angles. Isn't it so? क्या ये clear है? Okay. Now, if we draw, extend a line, let us say हमने extend किया line CD को. If you extend a line CD to E, so इस angle की value क्या होगा? This angle will be, since theta 4 plus this angle is supplementary as well because linear pair है, so this will be 180 degree minus theta 4, or we can say that this angle will be equal to this angle. Isn't it so? So that is also an important property of cyclic quadrilateral, that this external angle is equal to opposite interior angle, that is angle B. Is that part clear? कि angle ADE will be equal to angle ABC. Okay, and same as we discussed for in circle, every triangle has a circumcircle, but every quadrilateral does not have a circumcircle. ठीक है, all quadrilaterals does not have circumcircle. All quadrilaterals do not have circumcircle. Examples of cyclic quadrilaterals could be rectangle, square, and isosceles trapezoid. Isosceles trapezium. Rectangle, square, and isosceles trapezium. So, not all rhombuses. Mostly rhombus will not be a cyclic quadrilateral. Similarly, not all parallelograms. Okay, because rectangle and square are also parallelograms. So these are special parallelograms that are cyclic, not all. Okay, clear hai? Similarly, not all rhombus. If there is a special rhombus with equal diagonals, then in that case it will be cyclic, otherwise it will not be a cyclic quadrilateral. Okay, and in case of a cyclic quadrilateral, all these lines AB, BC, and CD and DA, all these lines are chords of the circle, chords of circumcircle. Isn't it so? All these lines are chords of circumcircle. So this is also called a chordal quadrilateral. All these lines are chords. So for example, हमने AB को as a chord assume किया. अब diagonals draw करते हैं. So one diagonal will be BD, other will be AC. So if AB is the chord, AB is the chord, so angle ACB, this angle ACB is angle made by the chord on circumference, chord AB on the circumference. Similarly, angle ADB is also an angle made by the same chord AB on the circumference. So these two angles are equal. Angle ACB will be equal to angle ADB. So if this angle is equal to angle 1, so this will also be, value will also be 1. ठीक है. Similarly, if you assume chord AD is also chord, AD is also chord. So from chord AD, one angle is ABD and the other angle is ACD. So these two will also be equal. Similarly, from chord CD, CBD is angle 3. Similarly, CAD will also be equal. And lastly, the remaining angles हमारे बच गए from chord CB, this angle and this angle. These will also be equal. Isn't it so? Okay. Next important property, same as ABCD, the sides AB, BC, CD and DA, the diagonals of the cyclic quadrilateral are also chords of the same circle. So BD as well as AC are also the chords of the circle. Chords of a circle. So as per intersecting chords theorem, intersecting chords theorem, if the intersection point is O, so AO into CO is equal to BO into DO. AO into CO will be equal to BO into DO. So the part of the diagonal one, ठीक है, diagonal one 2 parts में डिस्ट्रीब्यूट हुआ, AO और CO में 2 parts में डिवाइड हुआ, और सिमिलरली diagonal 2 डिवाइड हुआ 2 parts में BO और DO में. तो इंटरसेक्टिंग कॉर्ड्स के जो हमारे लाइन सेगमेंट्स बने, दो लाइन सेगमेंट्स का जो प्रोडक्ट है दैट विल बी इक्वल, यानी BO into DO विल बी इक्वल टू AO into CO. ओके, क्लियर? ठीक है. नाउ वन लास्ट प्रॉपर्टी, that is Ptolemy's theorem for cyclic quadrilaterals. Ptolemy's theorem. And as per Ptolemy's theorem, ABCD are the side lengths and AD and BC are the diagonals. The product of the diagonals is equal to AC into BD. This is equal to AB into CD plus BC into AD. So product of diagonals is equal to product of opposite sides का sum, यानी AC into BD is equal to AB into CD plus AD into BC. Okay. क्वेश्चन करते हैं अब. First question, if ABC is an equilateral triangle and DI is equal to 15, DC is equal to 12, then we have to find the side length AB. BD, side length BD क्या होगा? If DI is 15, DC is 12, तो side length DB क्या होगा? And ABC is given as an equilateral triangle. Pause the video and solve it. So if ABC is equilateral triangle, so AC will be equal to BC will be equal to AB, and DI is equal to 15 and DC is equal to 12, and all these values are, let us say AB is equal to BC is equal to AC, these are equal to X. DB की वैल्यू हमें फाइंड आउट करनी है, टॉलमीज थ्योरम अप्लाई कर देते हैं. सो AC into BD, so BD into AC, और AC is equal to X, तो BD into X, this will be equal to AD into BC यानी 15X plus AB into CD, that is 12X. So BD into X is equal to 27X. So BD will come out to be equal to 27. Straight up forward question. BD will be equal to 27. Easy question. Isn't it so? क्या ये पार्ट क्लियर है? ठीक है. नेक्स्ट क्वेश्चन. अच्छा, एक और पार्ट रह गया. लेट अस से देयर इज अ लाइन AB and there are 2 points C and D and angle ACB is equal to angle ADB. There are 2 points C and D and angle ACB is equal to angle ADB. These two angles are equal. And if this is so, in that case points A, B, C and D are concyclic. This implies that ABCD, ABDC in this case, because ABCD तो सीधे बन नहीं रहा, तो ABDC will be, एक सेकेंड, ये काम करते हैं, सी और डी को रिप्लेस कर देते हैं सो दैट प्रॉपर्ली ए बी सी डी लिख पाए. सो ए बी सी डी विल बी अ साइक्लिक क्वाड्रिलेटरल इन दिस केस. Cyclic quadrilateral. So vice versa is also true. If the two angles made by the same line AB on point C and D are equal, then in that case ABCD will be cyclic, cone cyclic, and will be forming a cyclic quadrilateral. Okay. Now let us say there is a quadrilateral ABCD and midpoints of AB, BC, CD and DA are PQRS, P, Q, R and S. And if we join these points PQ, QR, RS and SP. If these are midpoints, यानी कि AP is equal to PB, BQ is equal to QC, RC is equal to DR and DS is equal to SA. If PQRS are midpoints, in that case PQRS, this will be a parallelogram. Parallelogram, which implies that PQ will be parallel to RS and PS will be parallel to QR. So if midpoints of any quadrilateral, midpoints of the sides of any quadrilateral are joined, then the new figure is a parallelogram. PQ is parallel to RS as well as PS is parallel to QR. Okay, clear? Not just that, if we draw the diagonals of the original quadrilateral AC and BD, AC and BD, so now you can observe that in triangle ADC, as per midpoint theorem, triangle ADC में midpoint theorem से you can observe that S and R are midpoints of AD and CD. So if S and R are midpoints, in that case we know कि SR or RS is parallel to AC, and not just that, RS is also equal to 1 by 2 AC. RS is also equal to 1 by 2 AC. Similarly, in triangle ABC, by midpoint theorem, P and Q are midpoints of AB and BC. So PQ will also be parallel to AC and PQ will also be equal to 1 by 2 times AC. So hence PQ and RS will also be parallel and PQ and RS will also be equal. So by that logic, PQ will be parallel to RS and PQ will be equal to RS. Similarly, तुम देख सकते हो ट्रायंगल ADB और BDC में भी, so there QR will be parallel to PS and QR will be equal to PS. So that is why PQRS is a parallelogram. क्या ये बात अप्रिशिएट कर पा रहे हो? ठीक है, is this clear? And not just that, area of that quadrilateral PQRS is half that of area of ABCD. So area of PQRS, this is equal to 1 by 2 area of ABCD. और इन सारी बातों को जो भी हमने सेशन में डिस्कस किया, इनको शांति से तुम्हें समझना है. जहां जहां पे डाउट रहा हो, एक बार फिर से वापस उनको रिवाइंड करके देख लेना. ठीक है, याद करना बहुत जरूरी नहीं है, बट समझ लोगे तो वैसे ही याद हो जाएगा. ठीक है, एक बार तुम चीजों को देख लोगे, अच्छे से ऑब्जर्व कर लोगे, जो इंपॉर्टेंट फॉर्मुलाज है उनको तो याद करोगे, बट अदरवाइज बाकी चीजों को तुम समझ लोगे तो वैसे ही एक दो बार तुमने रिकॉल किया, उनको समझा तो फिर क्लियर हो गया वो. और क्या चाहिए? ठीक है, ओके. सो इतना ही रखते हैं इस सेशन में. आई बिलीव जो भी डिस्कस किया वो समझ में आया होगा. और फिर भी कहीं पे डाउट रहा हो तो मेक श्योर टू कमेंट अबाउट दैट डाउट, और एक बार फिर से सेशन को स्टार्ट से एंड तक देख लेना. जहां जहां पे भी डाउट हो वहां पे चेक कर लेना. ओके, एंड मेक श्योर टू गिव योर फीडबैक. अगर सेशन अच्छा लगा है तो मेक श्योर टू हिट द लाइक बटन, एंड इफ देयर इज एनी डाउट व्हाटसोएवर, कितना ही बेसिक डाउट हो तो एक बार कमेंट जरूर मेंशन करना. चलो, दैट्स ऑल फॉर दिस सेशन. बाय, टेक केयर एंड कीप लर्निंग.